Hi, everybody. Today I'm gonna start to talk about chapter number 3 in Map 110. So this chapter 3 will cover function notation, domain and range, and the quadratic function and parabola. So let's start with the function notation in section 3.1. So in section 3.1, we have example that y equal to 2x minus 1. And this is an equation or linear equation like you have learned as previous section. In order to change it to be the function notation, I will change y here to be f of x. And then now I'm going to have fx equal to 2x minus 1. And remember that in here, we call x is input. Okay. Input. And f of x will be, we call is output. Okay. So let's do some evaluation for this function. This is f of 2. What does that mean? That means in this case, the input equal to 2. So I have 2 times input minus 1. Input now is 2. So I'm going to plug into here, and I got 2 times 2 is 4. 4 minus 1 equal to 3. Similarly, I have f of negative 1 going to be 2 times negative 1 minus 1 equal to 4. No, sorry, equal to negative 2 minus 1 equal to negative 3. And 2 and f of 0 going to be equal to 2 times, now it becomes 0. Minus 1 will be equal to negative 1. Okay. What about f of 2/3? In here, in this case, the input becomes 2/3. So I have 2 of, let me change the other color so you can see it clearly. So 2/3 and minus 1. Now 2 and 2/3 will be 4/3. And I got chain number 1 here become 3/3 to make it the same denominator. So I can do subtraction between the fraction. And in order to do that, I just take the top. 4 minus 3 going to be equal to 1, and keep the bottom as 3. So the answer has to be 1/3. Okay, so let me move to the next page. Okay, so in this practice, I'm gonna have and the left-hand side column is x, y is the equation that using x, y variable, and the right-hand side is using function notation. So for the first equation, I'm going to use f of x, which is the same. Oh, sorry, not f of x. It is y, because we are using y here. It's going to be the y equal to 2 times x minus 1. That is a function as above. And that's going to notate my f of x equal to 2x minus 1. And for the another function, which is g of x here, I will have g of x equal to, I believe down here is have give us g of x with 2x squared plus 4x minus 0.5. 2x squared plus 4x minus 0.5. So let me make sure everything is correct. Okay. So now I have y will be equal to 2x squared plus 4x and minus 0.5. Let me use other color. For the f of -3, I will have I will have to use this function with input at -3. So I have 2 times -3 minus 1. And I will have what? -6 minus 1. And that's going to give me equal to -7. Okay, circle it. And now I want to find f of a. Remember that's now the input is a. Okay, so I have 2 times input minus 1. And what is input now? A, right? And I want to simplify this and rewrite as 2a minus 1. That's the answer. Okay, what about f of a plus 1? Do you know that? All the things inside the parentheses of f here is input. Okay, so input now is a plus 1. So I'm gonna have 2 times input minus 1. And what is input? A plus 1, right? So A plus 1. And I can simplify it by using distribution. I have 2a plus 2 minus 1. Combine like term. Excuse me. Combine term, I have 2a plus 1. 2 minus 1 is 1. So that should be the answer. Okay, now I'm going to use the color. So, okay, for g, I'm going to use this function. And g of 1 will be 2 times with input square plus 4 times input and minus 0.5. Input now is 1, so I put 1 here, and I'm gonna simplify it. So 2 times 1 is 2 plus 4 minus 0.5. And you may use your calculator and get the answer as 5.5. Okay, what about g of z? So I will have, in this one, input is z. So actually, we can just substitute all the x to become z. So I have 2x squared now become 2z squared because I now change the input x now become z plus 4z minus 0.5. That's the answer. And now I have z plus 1 as the input. So I have to change it 2 times with input square plus 4 times with input and then minus 0.5. Minus 0.5. So what is input? Z plus 1, and then Z plus 1. Okay. So I will have what? I will have to maybe simplify this by using 2Z plus 1 times Z plus 1. If you don't remember the formula for the Z plus 1 square, you can split it to become 2 factor like this. And then 4Z plus 1 minus 0.5. And then after you do this, you can do distribution, right? You're gonna have 2 times Z squared plus Z plus Z plus 1. And then plus 4. You can do distribution with this guy also. So 4Z plus 4 and minus 0.5. And also now you're gonna have 2Z squared, and you can have 2 times Z here gonna be 2Z plus 2 times Z here gonna be 2Z, and or you can combine these two, become 2Z, and 2Z times 2 here become 4Z plus 2, and then plus 4Z plus 4 minus 0.3 will be 3.5. And I'm gonna use that's the split out here. So I'm gonna simplify. So using 2Z squared stay, and plus with 4Z plus 4Z here become 8Z, and 2 plus 3.5 here will be 5.5. So I say plus 5.5. This is gonna be the answer for this problem. So go ahead. All right. So now I will move to the next page and see that they have the last problem as G of A plus 2 minus G of A. So you can note that G with input at A plus 2 will be actually the same thing as G with input of Z plus 1, but you change Z become A. So now I'm gonna use this guy and change Z become A. So I have 2A squared plus 8A plus 5.5. And then for the Z of A, it should be just 2A squared plus 4A minus 0.5. I just use the original function of Gx here. Change that to become A. So now I'm gonna subtract GA plus 2 by GA. I mean, subtract GA by GA plus 2. So you will have what? 2A squared plus 8A plus 5.5. Don't forget to have parentheses that this for the GA plus 2. And now you subtract for the G of A is 2A squared plus 4A minus 0.5. Okay, so now I will open the parentheses for the first term, 5.5, and then for the second term, because the negative in front of the parentheses, I have to change all the sign after the parentheses. So, and now I will cancel 2A squared, and I also will have 8A minus 4A gonna be 4A, and 5.5 plus 0.5 gonna be 6, so plus 6 gonna be the answer of this, 4A plus 6. Okay, so we're done with this practice, and I'm gonna move to section 3.2. Okay, so in this section, we're going to talk about the domain and range of a function. A function is a rule that produces a correspondence between two sets of numbers, such that each number in the first set, called domain of the function, corresponds to exact one number in the second set, called range of the function. The domain and range are limited by both mathematics formula we use as well as business context. So in short, let me say domain, which noted by D, is a set of input value, and range state noted by R, and then it is a set of output values. Okay, so let's do an example. So this is electric cost with a function as EK equal to 14 plus 0.1 K. In here, you should know that EK is output and K is input. Okay, so the question is, the domain is K, right? And also in here, this what kind of this function? I'm gonna say polynomial function. Okay, why is polynomial function? It doesn't have any radical. It doesn't have any what is it called, fraction form, and it doesn't have exponent form. So then we call it is polynomial form, polynomial functions. So since you see this kind, you can right away know that in the mathematics, the domain is had to be from the negative infinity to positive infinity. But the thing in here is this problem is, again, is electricity cost, which means it is real life problem, and it will be not like, it doesn't make sense if you have like the K in here is negative. I assume K in here is like how many kilowatt you use. So no way you're gonna have like a negative kilowatts using. So at least it should be equal to 0 or greater than that, right? So I would change it to be K greater than or equal to 0, because it is a real life function. Okay, so this one is just in mathematics, but this is like because it's a real life part. Okay, so remember that we have to have K greater than or equal to 0 as the domain of this, which is answer of this part. Okay. What about the range in this problem? The range is output of the function. And remember that this is like a increasing line about the electricity cost, and you're gonna see there is a fixed cost in here, which is 14, and it passed with something which is growing, right? So I'm gonna say the range in here, which is EK, had to be greater than or equal to 14. Okay, and it will not less than 14, because you start with the 14 and plus with something, right? Okay, so let me move down. Now, this is just math example, okay? So I don't care about any real life limit, okay? I just care about math. In here, what kind of this function? I'm gonna say radical function. And since it's a radical function, you had to know that the radicand, okay, radicand had to be greater than or equal to 0. Okay, what is a radicand? Radicand is the term or the group inside of the root. This is called radicand. Okay, so that is a requirement in order to make the radical function defined. Okay, so that means what? In here, domain inequality notation is x had to be greater than or equal to 0, because it is the x is radicand, and it's also had to be greater than or equal to 0. And I will have, if you remember the graph of the radical, when of the radical function y equals to square root of x, it should look like start from 0 and going like that. Um, I just graph like, you know, roughly. It doesn't have to be perfectly, but anyway. So the range in here is a value of y, or the sorry, yes, and also is a y value of the output. So in here you can see that the value of y is keep going up, right? From 0. From 0 here. It's keep going, it could be going up a little bit slow, but it just keep going up. You should know that. So I'm gonna say y has to be greater than or equal to 0. And can it be less than 0? No way. Okay. So I will move down to the next one. Okay, now another function that you may also consider about the domain we call rational function. I'm missing the, oh here, function. And in order to make the rational function defined, you need to know that the denominator has to be not equal to 0. What is the denominator? It is the term bottom here, the bottom things here, right? So in this case, domain had to be x not equal to 0. Okay, and the graph of this, if you remember, is had to be like a hyperbola, like that. I just remember that I just draw roughly. Okay, so this could be a little bit. You can take a look at the Desmos graph calculator, but it should be look like that. And you should notice that for the range, which is a y value, you can see that the y value will never equal to 0, right? You don't want to have the y equals to 0 because it just the y it just go along with the axis here, and I mean until it become like infinity. The x will become infinity, then y is gonna be go to 0. But you know, if that's way, that's only undefined. So we will call the range will be y not equals to 0 and y everything else. So let's move down. Okay. And here, another example about radical function. And you should know that if it is radical, then the radical is greater than or equal to 0, right? So so I have 2 minus x has to be greater than or equal to 0. Okay, so to solve this inequality, I have to subtract both sides by 2, and then I have negative x greater than or equal to negative 2, and then I'm gonna multiply both sides because I'm looking for the x, so I multiply both sides by negative 1. Since I multiply a negative number, then I have to change the sign of the inequality to be opposite way. So less than or equal to 0, and less than or equal to that. Okay, from greater than or equal to, now we change become less than or equal to. And 11 sine now become x less than or equal to 2. So the domain will give us as x less than or equal to 2. And you can see that from the graph here, you can see that the graph have step from the x here and going down, just keep going down to the left way. So that's the reason why you have x less than or equal to 2. What about the value of output or the range in here? You can see that y, the minimum y is here, right? It's 0 here, right? And it just keep going up. So a little bit slow, but still later on is going to be the positive infinity. So I'm going to say y greater than or equal to 0 for the range. Okay. Or I say x better. Okay. Now I'm gonna note down here. So I have one columns talk about the Calq company that can produce a maximum of 1,000. Okay, so remember the word maximum here of 1,000 calculators per day. And suppose that C of x equal to 250 plus 2x, where Cx is cost to produce x calculators per day. Okay, so here's a graph of y equals Cx. So from the given, I'm gonna say here is x maximum, right? Because it's a maximum of 1,000 calculator, right? So you can see that from the given, you have x max equal to 1,000. What about x mean? You don't want to have the negative number, right? Because this is a real line. And you're also going to see from the graph, the x max is here. X mean is here. And x max is 1,000. Okay. So x mean equals 0. So what does that mean? The question is, as a business example, what is the natural domain of Cx? Easily you can see that x has to be greater than or equal to 0 and less than or equal to 1, and 1,000 here. So that is a way for this problem. Now let me move that here. Okay, now let's continue with Calq company and its maximum capacity to produce 1,000 calculator per day, and cost function is Cx equal to 250 plus 2x. Okay. As a business example, what is natural range of Cx? In order to find the range, you need to know what is a what is the minimum of Cx, and also what is maximum of Cx, right? Okay, so let's start to find C of x max, which is here. In order to find C of x maximum, you have to check where is x max, where is this one? It is x max, which is 1,000. So I'm going to change it to become equal to C of 1,000. And I plug into the function 250 plus 2 times 1,000. And I will get 2,000 plus 250 going to be 2,250. Okay, so this is at 2,250. So the port has 1,000 here and 2,250. Okay, for the C, the cost mean is will be when x equals 0 here. So we're gonna have C of 0, which equal to 250 plus 2 times 0, and that's going to be equal to 250, which is a fixed cost over here. Okay, so this, I'm going to say 0, 250. And I'm going to say, oh, the range will be C of x in between 250 and 2,250. That's going to be the range. Okay. So now let me move down to the next page. Over here. Okay. Continue with calculate. Suppose it has a price function p of x equal to 2,500 minus 0.5x. Graph the demand function. Okay, let's grab it. So at first, I'm going to have 2,500 is going to be the fixed cost, which also going to be the y-intercept. So 2,500, where it is in between 3,000 and 2,000 here. So the middle one going to be this guy. So I have 2,500. Okay, now in order to get the h-intercept, I will let p of x equal to 0. Right? Set p of x equal to 0. So I have 2,500 minus 0.5 x equals 0. And I'm gonna subtract both sides by 2,500, and I get 0.5 x equals to negative 2,500. And then divide both sides by 0.5, negative 0.5. So I have x going to be equal to 5,000. So you can have the 5,000 is the x-intercept. And you can just connect these two points to get the graph. I hope I can draw a good line. Okay, perfect. All right, so a business example, what is the natural domain P of x if we ignore the calculate maximum capacity limit? Okay, so in this case, we ignore x has to be maximum x gonna be 1,000, right? So so we ignore that thing. So then you can see that from in order to make this function make sense in this real life problems, you can see that the input with is action here, it just go from the minimum is from 0 here, right? To the maximum is at 5,000 here. So I'm gonna say x is from 0 to 5,000. in this guy. I'm using the hide color. Yeah. So 0 factors. What about the natural range of P of X? So you have to look at the P of X. It is Y value. You see that the graph just give you the value P of X from 0 to 2,500, right? So I'm gonna say P of X is from 0 to 2,500. Okay. So let's move to the next page. All right. So still the same problem, but now if we include the CalQ maximum capacity limit of 1,000 carburetor, what is the natural domain of that? So we have, what's 1,000? Say, here's 5,000, right? So then here's 4, here's 3, here's 2, here's 1. 1,000 here. And that mean what? I just gonna include here, and I don't care about this at all, right? I don't want to use. I don't need that at all. So okay. So then now I'm just gonna care about the blue line here, and for the domain is now just from 0 to 1K. So 0 to 1,000, right? And for the range, you should know that is just gonna be the value just gonna start from 2,000 here. You can check, is that really 2,000 by substitute X equal to 1,000 into P of X, say P 1,000 here equal to 500 minus for 0.5. Run out space. P of 1,000 500 minus 0.5 to 1,000. So now use a calculator, it should be 2,000. Okay. 2,000. All right. So that means is that from it's greater than 2,000, and I use the other color, and until here is 2,500 according to the period or the fixed cost here. So P of X had to be between 2,000 and 2,500. Okay. So last one. Bendy Inc. make paper clips and sell them at the price of $P per 1,000 clips. Suppose that Bendy's profit function is given by negative 1x squared plus 70x and minus 10,000. The graph of Bendy's profit function is given below. can we read the range arc of the graph? And what's the domain of the fraction would you recommend for these? Okay. In order to find the domain, or actually in order to know the range of the class, you may have to see what is maximum of px, which is here. Minimum is 0, right? So it's go up to here. Okay. So range R is P of X is in between 0 and 2,200 2,250. What about for the domain? You should know exactly these 2 points. But in order to know exactly, you need to set P of X equal to 0. Because these are 2 X in the set. So say set P of X equals 0. Then I have negative 0.1 x squared plus 70x minus 10,000 equals 0. I gotta multiply both sides by 10 or negative 10. Okay, so multiply by negative 10. Multiply by negative 10. So we have what? X squared minus 700 x plus 100,000 equal to 0. And you can factor this by using AC method. Say A times C is 10,000 or 100,000. Right? A is 1 and C is 100. And B is negative 700. So 2 number, that's multiplication equal to 100,000 and addition equal to negative 700. So you can say negative 200 and negative 500. That's going to be the number, 2 numbers that you need to know. So then you want to factor this as x minus 200 times x minus 500, which equals 0. And then you're going to say x equal to 200 or x equal to 500. So this is exactly 200 and this is exactly 500. So then you're gonna say the domain of production group I would recommend is x in between 200 and 500. Okay. So I'm gonna stop this section here. And if you have any question, please go to my live Zoom lecture and ask me. I'm gonna see you later.